Hi everyone. In today's video we'll discuss the profiling process in the Pro 1600 Reflow oven. And in one of the prior videos we discussed profiling using the external thermocouple control or a closed loop method. This video will focus on the traditional profiling process where we create a profile, save it in memory, and then run it, recall it from memory for future builds. And that's the most common way of profiling in this oven, as well as the process in any other type of production reflow oven. Basically getting settings for a specific board design, getting the feedback of the board, and then developing that profile, saving it in the software, and then running it for future builds. So in this example we have a sample board that's placed on a loading tray with a thermocouple attached to the board. It can be attached to the board or pad, but this thermocouple is going to provide feedback of the temperature of that board relative to the settings we have in the initial profile stage. And you can have a single board, you can have multiple boards placed at the same time over that loading tray. It doesn't matter in terms of the oven. It has the capacity to compensate for the additional thermal mass. So either a single board or as many smaller boards that will fit in that 20 by 20 inch array. Also, this is a single-sided board. With a double-sided board, we would have a fixture over the loading tray, and it will clamp the board along opposite edges. So when running the board the second time around, there's a standoff between the bottom side components and the mesh of that loading tray. This way that there's no contact, no interference. But once we have the board in or on the tray, thermocouple is connected. In the software we have either a profile that we ran before that we can use as a baseline, or we can just pull up one of the profiles from a library that we have of predefined profiles. And in this example, this is the main cluster of settings we're going to concentrate on. We can create additional ramp stages, have up to 5 different ramp stages with their corresponding temperatures and time at temperature. But most of the time, it's a single ramp to a set point, time at a set point, and then we ramp to a peak temperature and then maintain that temperature for a certain amount of time. So while this is running, we're going to monitor the board temperature to make sure it's within the parameters we want it to be at, and then modify the settings of this profile or save it if it's acceptable. Just a couple of parameters. I'm going to check off that external thermocouple, and we're going to hit start. So the tray is going to come inside the chamber, cover is closing. The thermocouple is positioned between the cover and the frame. There's a flexible seal, so that prevents that thermocouple from being cut or damaged as the cycle is running. So here we have the control, which is the red line, and the blue line is the thermocouple that's tracking the temperature on the board. Unlike the previous video where we have the control based on the external thermocouple control, this is the internal control. This is the most common way of profiling, and the blue line is only a feedback thermocouple at this point. It's only showing us the board temperature it's not dictating this process. The process is being controlled by the red thermocouple, and that's inside the heating chamber. And the settings that we have in this profile are based on that. So what we're looking at is the temperature of the board, and it will help us to determine whether we need a longer soak time or maybe a different temperature set point. One of the things here is that we can make adjustments on the fly. So if we see that there's a wide delta between the board temperature and the air temperature, we can go back in the profile tab, make adjustments on the fly. So I'm changing 50 seconds to 70 seconds, and there's no need to wait for the profile to cool down and rerun it. So we can optimize it. We can really tailor this profile in a single pass. The board is at 173, 175. So we're now going to go from the preheat stage to the peak temperature, and that's 265. Now I have 30 seconds programmed. To be safe, I can change that to 100 seconds and monitor it as it's running. So if it ends up that 100 seconds is too long, we can go back, reduce that temperature, reduce that time from 100 to maybe 60. If I see I'm getting to that desired peak temperature sooner. So right now the board is approaching 217, which is our melting point, and with a lead-free board we want to get to about 230 to 245 C. So we're approaching 230 Celsius as measured on the board, and we're about 50 seconds into that 100-second time period. So I'm gonna go back. We're at 235, and I can reduce that 100. Let's make that 80 seconds. And we're at 240 on the circuit board. About 245, and right around this point we're going to go in the cool down stage, where the lid's going to open up, the exhaust is going to turn on, and it's going to pull the hot gas, pass it through filters, and cool the board. Now you also have external fans if that's the configuration, and the fans are going to continue to cool the board down further. So looking at the blue line, we're able to determine if this is an acceptable profile or if we want to make some adjustments. You know, if 245 is on the high end of it, I can go back and reduce the time. You can also modify the temperature, but primarily, you know, this is the section of values, the time values at the initial set points that we'll kind of play around with and make adjustments to. And you know, the profile looks like it's within the settings. Time above liquid is approximately 80 seconds, maybe 90 seconds. we can save the screenshot. We also can click on Save Data and basically just save the raw data file. That data file is a text file, so it can be imported into Excel, but if you have that documentation, it's going to show the individual temperature and time parameters, taking a reading every half a second, and as well as the profile. But once this is complete, if we're satisfied with the profile, we would click on Save Profile, title it XYZ, whatever the name of the board is, click OK, and the settings are going to be saved. So anytime we run, or we want to run the same board design again, whether it's one board or as many boards that will fit in that array, we'll run the same profile, and there's no need for using the external thermocouple anymore. We established the profile. And that's basically it.